In this video, we'll talk about the difference between asynchronous and synchronous executions in the Grand Central dispatch queue. So the first thing we're going to realize is that the difference between asynchronous execution and asynchronous execution is for the caller. It doesn't have to do with any, like how the tasks are handed to the thread, because that's determined by the dispatch queue that you choose, right? So here we're gonna walk you through the difference using this example. So we have this demo view controller. I modified two lifecycle method, the view did load, which sets its background color to red, and then I also modified the view did appear and set the background color to green. So the reason we did this is that I want to show you how the process of loading a remote image into this UI image view using dispatch queue. So to create a dispatch queue, as you've already learned in the previous sections, we're gonna call the dispatch queue class, right? And in its class, it has several the class property. The first because we have two types of dispatch queue. We have main or we have global. These will be the dispatch queue that you'll be most likely be using, right? So we're gonna choose a global, and for the QoS, because it's loading an image, it might take a while. Like for the most part, it should use a background, but we're just gonna use we can use a utility, I'd say. And then here comes the important part. Here, after you select the dispatch queue, you have the option to select whether you execute a code synchronously, as in the first option, or you can execute it asynchronously, like in the first option, or you can execute it synchronously, like in options right here. So we're gonna try out synchronous execution first, right? The biggest thing for synchronous execution is that the control to the function, the control flow is returned to the caller once this code block, the code block that you pass into sync, is returned. So let me show you what I mean by this. Because what we're trying to do is trying to load the image into the image view, right? So let's just uncomment this chunk of code, which takes in a URL and load that URL, the content of that URL into our data, which is a built-in, sorry, I need to clear this out a little bit. Let's just name it image, and we expect it to return an UI image optional type. So again, this is a URL, and here is the content of that URL in terms of a Swift built-in data class, right? And we have the error checking for returning no. So after this data, we're gonna return UI image with the content of that data. So I remember it should say, oh my god, UI image, and the initializer should say content of file or data. Yeah, it's data. So we're just gonna initialize it like this, right? And here you see the biggest thing for synchronous execution is that you have this opportunity of giving it a return, because what we're essentially doing here is inside this view that appear function is that we're waiting for the global synchronous function to return, right? And fetch the return data and assign it to a variable. That's why we can do this let assignment here, right? And after the let, we will be able to assign the image of that image view to that UI image instance that we just created. However, this creates a huge issue, as we were talked about before. Now, I sort of exaggerated using what's called a network link conditioner to show you that, what's gonna happen in terms of a very bad networking situation. As you can see, our view stuck at a red background color, for a fairly long time before, loading the image and turning it to green. So there are a couple of things to notice here, right? The first thing we're gonna notice is that the image are loaded at when the background color is set to green. It's not like you load that image and you just leave it there, let it do its job, immediately set it green, and then, you know, like when it's done, you load that image. You load the image into the image view. It didn't work like that, because what we're essentially doing again is like we waited for this dispatch queue global synchronous function to return before we move on, right? That's the whole concept of synchronous execution blocks the caller thread. So this is the big issue, right? Because for that whole, what I would say like 3 seconds, our UI will be completely unresponsive. Like you see what happened, like the view stuck at red, and then, you know, like it just stuck inside this view.appear function, and it won't do anything, right? So this is generally a very bad programming practice, and we would want to avoid that. So let's see how we can sort of fix this using a synchronous function, right? So we're gonna have the like roughly the same thing here, except we're just gonna say async. So the biggest thing that we're gonna notice immediately is that we don't have that option to return anymore. Because, I mean, think about it, that makes sense, right? When you're executing asynchronously, what's happening is that as soon as I execute this line, you know, like I send this whole block to the global queue utility, I just move on. I immediately move on to the next line of my main thread. I don't wait here anymore. And because I don't wait here anymore, I can't wait for its return, right? This is why we don't have that opportunity as we did for asynchronous execution, that, you know, like we can return a value as the result, right? So we don't have that option anymore. So I'm just gonna say return, right? Because I'm not gonna return no anymore. Return just means that, okay, I'm done. I'm not returning anything. So here comes the big issue. So how are we gonna pass our data back into the you know, like our demo view controller? So there are a couple of ways, but the most common pattern that we're gonna see, you know, in your iOS development career is gonna be what's it called, like the completion closure. So a completion closure is basically something that a function that you passed into this asynchronous chunk of code that gets executed when, you know, you are done, when this chunk of code is done. And because it's stored as a function, it will be able to it stores as a closure. It will be able to capture self as a reference and then use that self to modify our view controller. And let me show you what I mean by this. So let's just start by making a variable called, you know, like completion. Usually you wouldn't do that. Usually you would just, you know, like pass it in, but it's just for clarity. Let's just explicitly declare this. So for completion, I'm gonna make it a closure that takes in nothing and then returns nothing, right? This is the definition of a closure that, you know, takes in nothing and returns nothing using, you know, like a parentheses and an arrow. And then I'm gonna initialize. I'm gonna define it. Let's say first we're gonna capture self. You know, like we haven't talked about this, you know, like the whole capture list and stuff, but you just know that the closure will capture whatever is in this context. In this case, we're gonna capture self, the instance. So here we're just gonna say we're gonna pass in something. We can't pass in nothing because, right, we loaded an image as an UI image instance. We want to pass into the completion. So we're just gonna say UI image right here. And inside, I'm gonna say image, right? Image in. And here, because we captured self, we have access to this image view. We can just do it like we did before for the synchronous dispatch queue, synchronous execution. We can just say self.image equal to the image that was just passed in, right? So, you know, take a moment to kind of contemplate how this code is gonna work. This is a completion, is a function, is a closure, and we're gonna use that closure. We're gonna pass it into our asynchronous code, right? And once it's done, right here, we're gonna call this completion, right? We're gonna call this self.completion, and self.completion, and then pass in that image that we're going to create. So we're going to do the same thing. UI image. I forgot again. It's what's called it. The data. Oh yeah, data. So data, right? And we're probably gonna force on rapid because just we know where it's safe, right? So here we're done. We created sort of a mechanism. Oh, sorry, it's not this completion. It's because I declared that as a local variable. It's not self, right? So it's just completion. So right now we create a mechanism sort of letting asynchronous function, do something with its results after it's done. And you will see this pattern like everywhere, like inside like other APIs, or like in a Firebase function, in a Firebase authentication, or in a URL session data task. You'll see this pattern everywhere, essentially. So let's just take a look at how our fix works, right? So the first biggest difference you're gonna see is that our UI is no longer stuck. Okay, sorry, I made a mistake. So we'll talk about it a little bit later. We'll just first talk about what's happened on the right side. What's happened on our simulator. So the first thing we're realizing that is that our UI no longer stuck on this red, right? Because what we're saying with this async is that we don't wait for it. Immediately after we send it to the dispatch queue, we move on to set it to green. The effect of this, however, is that this chunk of code no longer blocks the execution on the app run loop or on the main thread, on our UI thread. So if right now we have our UI components going on this screen, we'll be able to perfectly be able to interact with it while our image is loading. So the second thing is actually we're gonna address this issue right now. It's actually a pretty good example. Is that take a look at the warning that our runtime sent us. You see, UI image view the image must be used for main thread only. So this should immediately rings a bell, right? Because when we talked about UI, how UI works, we talked about how it has to be executed from the main thread. So this is what's happening here. We assign this task to a global dispatch queue, and inside this dispatch queue, we call a completion that uses an UI. And because UI updates must happen in a main thread, this is not allowed. Basically, this is gonna be something wrong. So what we're gonna do is that we are gonna reassign this task back into its main queue by using the dispatch queue dot main dot. We can make it async or sync. Like it's not gonna make a big difference here because we're essentially blocking nothing, right? We're just gonna do this and rerun our app. We should be able to see, our UI, it's responsive. It's switched back to green while this image is loading. It's taking a while because, it's the network link conditioner says that there is like 10% of package loss, and the delay is 500 milliseconds only. Bandwidth is 1 megabytes per second. So that we can't fix that. Like apparently you can't like force your user to go to this spot as a better Wi-Fi, but we can make our app better cope with such network disturbance. And as you can see, although it takes a while to load, our UI is perfectly responsive, and our image shows up after it's done loading, right? So this is the power of dispatch queue. Like you'll be able to create this very complex loading or this scheme, and still be able to retain the responsiveness of your app, despite that you have some very time expensive operations going on. All right, so this is so much for this video. I'll see you next time.